Yep. Good evening, everyone. So, Shani, let's start off. Hope everyone started solving HCV. Chalo, others comes on. So this was the last thing that we did. Self energy.
Sir, we haven't done the self energy in class.
ठीक है ना? That the small part we are little head.
So what should I do? Matlab, how
Nothing.
many should I do?
I'll send you this thing now. Sirf 15 minute का concept है. You can just watch the recording or you're not there na next class. ठीक है ना? I'll teach you later on. Now. Relation between field and potential. It into self energy. What is the last thing we did, Pavitra, there?
Sir, last we have done is the matlab field pressure.
Hollow sphere, solid sphere, ka just results we did, na? I think field inside a cavity kiya?
No, we've not done field inside no, we did field. No, we've not done field inside the cavity. We did that.
Then you are coming on Monday, na?
I am there on Monday.
Actually, वो topic हो गया रे यहाँ पे. Then I think वो topic हो गया यहाँ पे. This we will do it on Monday, I think mostly. But ठीक है, at least ये part finish of this part, then we will see. So relation between field and. So I was thinking I'll send you the. हाँ वो हो गया topic actually. I'll send you the recording for that. This batch went ahead by one thing, one class. Next thing, see relation between field and potential here. So work done is given by F bar dot dr bar, and we know work done is nothing but charge into potential difference. Force is nothing but charge into field.
Sir, sorry to cut you in. Can I just ask for a small favor? If you could just rightly see over the PDF how many pages I could leave, so I can write today at least.
I can't say. I don't know from where it is.
We have last done field pressure.
So from here we did almost. You can leave at least 6-7 pages.
6-7 sides, no?
Yeah. हाँ 6-7 sides हो जाना चाहिए.
Thank you, sir.
चलो other scams on Hanamai, Divyanshu. So dv is e dot dr. So we have two forms in this. So integral dv is integral this is actually a minus sign. Wait. So dw is actually minus du is f bar dot dr. This I hope you remember. Work done by internal conservative forces is negative of potential energy. And potential energy is nothing but charge into potential difference. This is charge into field into dr. Q will cancel. You end up with dv is equal to e bar dot dr. So if you integrate this, you end up with VA minus VB is equal to minus integral E dot dr. This is an integral form. So limits will be from B to A. So when to use this, if someone gives you electric field and they ask you potential difference, we have to use this formula. So negative indicates in the direction of the field, potential decreases. Another way to write the same formula, right? You can write this thing also as, so dv is minus E dot dr. The field can be written as minus dou v by dou x minus dou v by dou r, which can be written as minus dou v by dou x I cap minus dou is a partial differentiation. Hope you remember. J cap minus dou v by dou z k cap. This is the differential formula. Please note down these two. So when to use which one? If someone gives you electric field and they ask you potential difference. If E bar is given and we have to find potential difference. This thing, if potential is given and they ask you to find field. Put that up. So this dou here is partial differentiation. Huh? Clear? And then copy the formulas. Let's see how they'll frame questions on this. That's it. In relation between field and potential, that is the main thing there. Let's say someone gives you like this: V is equal to x y square z cube. Find the electric field at the point 1, 1, 1. How to do this? Try this. So I gave you potential and I'm asking you for field. Remember partial differentiation? See, I'll show you one. What is dou v by dou x? When you differentiate dou v by dou x is constant, x is variable, everyone else is constant. So y square z cube. Dou x by dou x is 1. What is dou v by dou y? X, y square ka differential is 2y into z cube. What is dou v by dou z? Z is variable, everyone else is constant. Y square 3z square. Got this? So what is the field? Minus dou v by dou x now, minus y square z cube I cap minus dou v by dou y 2xy z cube j cap minus dou v by dou z 3x square z square k cap. You said you want field at 1, 1, 1. So just substitute here minus I cap minus 2 j cap minus 3 k cap. That's how you do. Now using this as a reference, can you do for this? Let's say it is xy plus yz. Can you find field at 1, 2, 3? Try this. Potential is xy plus yz. Find the field at 1, 2, 3. This is how you do partial differentiation. Do you remember where we saw this first time? Work power energy. Relation between force and potential energy. Dou u by dou x I cap, dou u by dou y j cap, dou u by dou z k cap. Force ka. Get this one. XY plus YZ. Minus 2y minus 3j. Okay. Dou v by dou x will be how much? There is no x here, so that will be 0. So that will be y. Dou v by dou y will be x plus z. Dou v by dou z will be also y. Agreed? Check karo. So the field will be minus yi cap minus of x plus zj cap minus yk cap. Y is 2, so minus 2i, x plus z is 4 minus 4j cap, and minus 2k cap. That's your answer. Please check how I did this: dou v by dou x, dou v by dou y, and dou v by dou z. Partial differentiation. If someone gives you potential and they ask you field, this is how you do that. Clear with this? Any doubts on this? Anyone? Clear, na? Trisha, Divanshu, Reena, clear? Labdi, Brinda, clear? Amu, got this? Next one, turning the page. Same thing, they can ask you like this also. Suppose if I give you a graph between voltage and the x coordinate, if you give you a graph between voltage and the y coordinate, and if I give you a graph between voltage and z coordinate, 30 degree, 60 degree, 45 degree, like this. Find field in the region. अभी क्या करेंगे? We are just playing with potential, huh? First part. Break into components. Actually, components में break हो गया है. I gave you Vx graph. मतलब voltage versus x-axis, voltage versus y-axis, voltage versus z-axis. Voltage varying on x, voltage varying on y, voltage varying on z. And they're asking you find the field in the region. What is dou v by dou x? Isn't it the slope? Slope है ना? Dou v by dou x क्या होगा? Slope, right? What is the slope? Minus tan 30 ना? Or minus 1 by root 3. What is dou v by dou y? Tan 60. What is dou v by dou z? Minus tan 45. Right? So what is the field? Minus dou v by dou x I cap minus dou v by dou y j cap minus dou v by dou z k cap. So dou v by dou x is 1 by root 3. So it is 1 by root 3 I cap minus root 3 j cap plus k cap. Please check. Because in a Vx graph, the slope is dou v by dou x, but the field is minus dou v by dou x I cap. So I can, from the graphs also, I can get the field. Harsh, I think you got it. Yeah. Clear with this thing? Hasni, clear, no? Got this, Kavya? Geet? Pavitra, clear with this? Graphs? Dipanshu? Divyanshu, clear? Divyanshu, you are wearing a cap, yeah? Why? Now you can wear, there is no restriction as such, but totally fine. Any doubts on this? Next one. Okay, so there are field lines like this. There is a point A here and there is a point B here. Compare the magnitude of electric field between A and B. Who has more electric field, A or B? Who has more potential, A or B? So electric field lines are given and there are 2 points A and B. Who has more field, who has more potential? Okay. Try. Everyone, I'll give you 30 seconds. Theoretical question. Right, Raina. Harsh, both of you got it right. Others, what do you guys think? You got an answer, you should definitely type here in the chat box. What do you think? See, what is electric field definition? The number of lines per unit area, right? E is proportional to number of lines per unit area. Therefore, EB is greater than EA. What about the potential? Remember, we wrote a definition. In the direction of field, the more you travel, the potential decreases. In the direction of field, the potential decreases. So when you're going from A to B, what will happen? VA is greater than VB. Easy? So basically, as you're going, think of it like this. It's like the more you travel in the direction of the river, the lesser the energy you can extract from the system. The meaning of potential, when I say potential at a point is 10 joule per coulomb, meaning from this point, you can extract an energy of 10 joules if you go to infinity. Easy? All got this? Next one. So we have 2 points here, A 1, 1, and we have B 2, 3. The electric field E is given by 2I plus 3J. Electric field is Xi plus Yj. Electric field is Yi cap plus Xj cap. So electric field is Y square I cap plus 2xy j cap. 4 different questions. Find the potential difference between A and B for these 4 questions. If the field is this, find VA minus VB. Field is this, find VA minus VB. Field is this, VA minus VB, VA minus VB. I'll show you one for you guys. So the formula is VA minus VB is minus integral E dot dr. So E is nothing but 2I plus 3J. We did the same thing in work per energy. Dot dr is nothing but dxi cap, dyj cap plus dz cap. That is the meaning of dr, people. R bar is a position vector, dr is a small position vector. Do the dot product. 2dx, 3dy. You're going from A to B. So this is you're going from B to A. PA minus VB final. So XB, which is 2. XA is 1. YB is 3. YA is 1. Integrate this, you get minus 2, 1 minus 2. minus 3, 1 minus 3. That will be 2 plus 6, 8 volts. Got how I did this? This is the formula of VA minus VB is minus E dot DR. E bar DR I know, DXI cap, DYJ cap, DZK cap. First do the dot product. Dot product will be 2 into DX, 3 into DY, Z is there is nothing there. And then just integrated it. Please check. Using this, can you solve the remaining 3? Try. I'll give 3 minutes. Anyone has a doubt in what I did here, please ask. Remember, what we did here is VA minus VB, meaning final, initial. So A is final, B is initial. That is the meaning of VA minus VB. So the limits will be A will be upper limit, B will be lower limit. That is one thing general people get confused. So be careful. That will mess up the whole sign. VA minus VB. So A is final and B is initial. So upper limit is A and lower limit is B. What is B ka answer? Try. Everyone should try. Don't keep staring. You should try. At least get a wrong answer, but try. Anyone confused with what I did in this example, meaning this first one here, please ask. I'll explain again. Someone got 6 volts. Harsh got B ka answer 6. Okay. In this, especially C and D are pretty good ones. Rishi, got some doubts? Yeah. Eleven by 2. Hasni got 11 by 2. Xi plus Yj. So VA minus VB integral, this guy will be Xi plus Yj dot dxi dyj dzk minus x dx. I think you might be right, Hasni. A to B ka limits, huh? So 2 to 1 and 3 to 1. That will be minus 1 square by 2 square by 2. 1 square minus 3 square by 2. That will be 3 by 2 plus 8 by 2. 11 by 2. You're right. Harsh, check your answer.
So can you show the question?
Third का 2x plus y कैसा आएगा रे? I know what you did. तो integration में x को constant ले लिया. There is a name for this kind of differentials. किसी को याद है? I taught you work for energy. Do you remember this question? Did you see? I didn't even change the numbers. 1, 1, 2, 3, 2y3j, xi, y, yi, xi. Exact same numbers. Change कुछ भी नहीं किया मैंने. We did this thing. There's a name for these things called. What are this? Perfect differentials. Let me show you how to do the third one. Third one is yi plus xj. So when you integrate VA minus VB, minus y dx plus x dy. You can't integrate this. You can't say like this. You can't take y outside and integrate dx. Blunder. Y is a variable, x is a variable. So, but together you can do something. You can write this as d of xy, isn't it? Product rule. You can't integrate y dx, you can't integrate x dy, but together you can make it into a combination called d of xy. Is that clear, everyone? Sure. This way of writing is called perfect differential. You guys should refer the work per energy ka notes once. Getting it? And then what you do after this? Where did she leave? So d of xy, how much is this can be written as? So this will be xb yb, which is 2 into 3, 6. This is xa ya, this is 1. So this will become xy, limits will be 6 to 1, which will be minus 1 minus 6 is 5. Understood what we did? Right, everyone? Got it what I did? So you can't integrate y dx plus x dy. You can treat this entire xy as one term. Let's call it t. So this will become tb, this will become ta. Is that making sense? This is how you integrate perfect differentials. Please check this once. Can you try the d part? Try the d part. This is also perfect differential. Now you need to figure it out. Whenever you get an equation like this, there are two ways to solve. Either it's a perfect differential, or else they should give you y is equal to x square, y is equal to x power root x. ऐसा कुछ देना चाहिए. If they don't give you relation between y and x, you can't solve the problem. But if they insist you can solve, it's a perfect differential. There is no other way we can do. So this is a trick. Keep that in mind. If they give you relation between y and x, then it is fine. If they don't give you, it's a perfect differential. What is t? Try 2 minutes. It's a good one. Okay. This page, Amu. Next one. Please check. Anyone confused, please ask. Rishi, remembered perfect differentials. Nishita, clear, na? Perfect differential part. Reina, Harsh, clear. Abhiksha, your cam is still blank, right? Still can't see you. Don't know what is happening with your cam. D part, everyone.
Sir, I'm coming in the room.
There will be. Na Remu, you're saying to reverse Karli. That is right. How to make this a perfect differential? $17 volts. Two people got the same answer. 17 must be right. How to do? How to do? Look at this. Integration. Right, Hasan. That is integration. So E is y square. क्या था वो? Y square ना? y square I cap plus 2xy j cap. So when you do VA minus VB integral, you end up with actually y square dx plus 2xy dy. This is nothing but integral of d of xy square. Check. Isn't that xy square a differential? Sure. And then you're done basically. So this is xb, yb square. Xb is 2 and yb square is 3, that is 18. This is xa, ya square. So basically you created x into y square as a new term. The limits also will be in that term. So this will be 1. So this will be xy square. The limits will be 1 to 18. That will be minus 1 minus 18, 17 also. Check. It's a good one. Huh? D is a good one. This is the kind of questions you can expect. Perfect differentials. Please check. Clear? Next one. Can I turn the page? So now here, this way, right, I can create different types of perfect differentials, like let's say d of x by y square. Different forms you can create. So examine how it will click is, if you give me something like this random, either you have to give me a relation between y and x, you have to tell me like y is equal to x square. Then your life is easy. I'll put y here and integrate. If you're not giving me that, kuch to hoga perfect differential. That you need to guess actually. It's mostly a product rule. Next thing, we have an infinite line charge, lambda. There's a point A here, there's a point B here. This distance is R1 and this distance is R2. Find VA minus VB. Do you remember field due to infinite line charge? Field due to infinite line charge. What is the formula?
Field due to
Infinite line charge.
2k lambda by d.
2k lambda by r, right? Or 2k lambda by r. Same thing. D is the distance, perpendicular distance from this. You guys didn't revise, everyone else. Solve. So what is the field ka formula? 2k lambda by r or d, anything you want you can take. So VA minus VB is minus integral 2k lambda by r into dr. You're going from A to B. So this is B to A. So this is RB, which is R2, RA is R1. Remember, A is final, B is initial. Minus 2k lambda, this will be ln r, limits will go from R1 to R2. This will be ln R1 minus R2. So send minus there, it will become 2k lambda R2 by R1. Check, easy. You get a ln function there. This is another standard model. Right? All clear with this? Any doubts on this? So basically, if I give you field and ask you potential difference, use the integral form. If I give you potential and ask you the field, use the differential form. Clear with this? Turn in the page. Next one. E is 0, V is 0, E is 0, V is not 0, E is not 0, V is 0, E is not 0, V is not 0, E is 0, dV is 0, E is 0, dV is not 0, E is not 0, dV is 0, E is not 0, dV is not 0. So there are 8 options like this. Which of the following is true? Which of the following is possible? Meaning, can you find a situation where E is not 0, but V is 0? Can you find a situation where E is 0, but dV is also 0? Like that. Which of the following is possible? Meaning you can create any kind of charge distribution you want. Which of the following are possible? Eight options. Multiple answer questions. I hope you're getting what I'm asking. So is there any situation where E is 0, but potential is not 0? So like that, you have to tell me. Indirectly, I'm asking you which is not possible. Think. I'll give you a minute. It's a good one. It's a good theoretical question. There's a small people goof up kind of. There's a certain thing people get confused with. Let me help you with that. But try. I'll give you a minute. Is first one possible? Possible, no? Don't keep any
No.
charge.
The third one is not possible. First, second is possible.
क्यों possible नहीं है? देखते हैं. Second is possible. कहाँ पे? Hollow shell.
Inside a
If you take a hollow shell, inside field is 0, but potential is kq by capital R. Remember? You can have field 0 in this thing. Third q0 नहीं है पवित्र.
third 0 नहीं है क्योंकि I to use this ये that the potential is force and E field is energy.
देखो,
तो force के
plus q
बिना energy
minus
नहीं.
q, okay? Plus q minus q. Center में field क्या होगा?
Center में field
ये
हाँ
0
shooting
नहीं
है.
है ना, but potential 0 है ना, scalar था. If you take two unlike charges q minus q, center में field is not 0 ना, field 0 मतलब null point था. But potential is 0, right? It's a scalar. So C is also possible. D is anyway possible. A, B, C, D are possible. Now, what is the confusion here? I'll tell you. See, this is where people get confused. What is the relation between field and potential? E is equal to minus dV by dr. E is not equal to V by R, people. Blunder hai wo. V and dV are not same. Are you getting it? For example, if you have potential 1, 1, 1, 1, 1, is the potential 0? Potential is not 0, but change in potential is 0. Are you getting the difference? Potential, change in potential are not same. For example, if V is 1, 0, minus 1, right? Is the potential 0? यहाँ पे V 0 है ना? But the change in potential is not 0. Are you getting the difference? Potential and change in potential are not same. Therefore, if you look at here, if E is 0, V has to be 0. dV has to be 0. Or vice versa. Are you getting this? So this is right. This is right. These two are gone. Are you getting this? So exam mein what they'll do now, they'll ask you this question. You guys will mark this answers and come. Because you will think E is V by R. V and dV are not same. They're quite different. Please check this thing. It's a good theoretical question. This is what they'll do. Telling you, they'll ask you this question. People mark these answers. That's why I kept all of them in one page. So you can actually compare. E, dV and V are not same. V and dV are not same. It's like saying position and rate of change of position. Are these two same? ये velocity हो जाएगा ना रे? They're not same. The moment you differentiate it is something else. Is this clear, everyone? Easy? Got this? Great. Next one. Equipotential surface. So what's an equipotential surface? A surface or the region where the potential is same throughout. Such a region or a surface is called equipotential. Example, if you take a hollow sphere with a charge, what is the potential inside a hollow sphere? Everyone mug up the formulas, huh? Because next chapter will be gravitation.
KQ square by single like the radius wala
Na, single Q आएगा, KQ by R.
portion.
Got it? So inside entire thing potential is same. This is an equipotential region. If you go outside at a distance R, this shell ka potential is KQ by small r. Means anywhere on the shell, the potential is same. This is an equipotential surface. Are you getting it? So we have different shells. Anywhere on the surface, the potential will be same. Right, Rhythm? Are you getting this thing? So for a hollow shell or a point charge, if you take concentric spherical shells are equipotential surfaces. So in this case, concentric shells are equipotential. So equipotential definition is simple. The potential is same, it is same everywhere. Can you give me one more example? Shell नहीं
Infinite
चाहिए.
wire,
Infinite wire का कैसा दिखेगा?
cylindrical equipotential.
So if we have an infinite wire, if you look at the symmetry there, यहाँ पे cylindrical shells are equipotential. So coaxial cylinders. One more example.
Equilateral triangle.
Equilateral triangle. उसमें equipotential कहाँ पे आएगा रे?
Center.
इक्विपोटेंशियल सरफेस
Okay.
भाई पे एक पॉइंट है.
Okay.
We need a surface. One more example, anyone?
Infinite sheet.
Wire
ठीक है,
through hollow
infinite sheet हम
cylinder.
through hollow cylinder ने plus Q minus Q. Can you tell me where is equipotential?
Null point.
Null point है ही नहीं इसके लिए. God. Plus Q minus Q का null point नहीं होता है. Center में the bisector plane ना. Because every point from here is equidistant, isn't it? Every point is equidistant. Potential is 0. The bisecting plane. Are you getting it? A perpendicular plane, perpendicular to both of these two guys, and in the center will all points have zero potential. 0, 0, 0. Everywhere it is 0. Because no matter where you take it, they'll be equidistant. Make sense? There. So those are some of the examples. Clear with the examples. Any doubts? Next thing. Properties of equipotential surface. First thing, work done in moving a charge on equipotential surface is 0. Obviously, because every point has same potential, potential difference is 0. So you not put any effort on moving an equipotential charge. So this equipotential surface, right? In space, we have something called Lagrangian planes. Lagrangian points, ऐसा कुछ concept है. So in space, what happens now? It is not a single planet, right? We have sun also, we have Earth also, we have moon also, we have other planets also. So let's say if you're traveling from Earth to some other planet, there are certain points in the plane which are equipotential actually, gravitational equipotential. So these people, what they do, right? These NASA people, they actually use supercomputers for this. They try to calculate these equipotential surfaces in the 3D space, right? Using supercomputers. So when you're launching a satellite from one point to another point, let's say you have to go from here to here. So what they do, instead of going directly, they will try to reach here. Then automatically it will go till here because there's no energy needed. And then again it goes from here. You're getting it? So next time when you think, why do NASA people need supercomputers? It is to calculate trajectories and paths. You can save a lot of fuel, right? So they do such kind of things. So equipotential surface have a huge advantage in space navigation. Second thing, the electric field lines are always perpendicular to the equipotential surface. Right? Reason, think of it like this. Let's say this is equipotential surface. Suppose if you have a field like this E making an angle theta. So this component E tangential will be E cos theta. So E cos theta is tangential. Remember we wrote a statement in the direction of the field. What will happen to the potential? Decreases. So in the direction of E cos theta, that is on the surface, the potential should change. But you said it is an equipotential surface. but it is equipotential. Therefore, E cos theta cannot exist. Are you getting the logic? If there is a parallel component, the potential will change. Therefore, E cos theta is 0 implies theta is equal to 90 degrees. So, first example, if you take a charge Q here, you will observe if these are equipotential, the field lines, if you observe, no, they're always perpendicular. They're always perpendicular to the surface. Okay, have a look at this page. That's the second property.
Sir, one doubt. At an equipotential point, the electric field is 0, right?
No, who said? Electric field tangential is 0. Perpendicular हो सकता है ना?
But like in the earlier question we read dV is 0, so E should be 0.
dV is 0 in which direction? This direction, na?
Oh, okay, yeah.
So in that direction, the field won't be there. dV can change in this direction. Remember the formula, actually it is not dV, it is dV by dx, I cap, dV by dy, j cap. There are 3 components. So in a particular direction, if dV is 0, in that direction field is 0. Got it?
Yes, sir, understood.
Third, equipotential surfaces cannot cross each other. Same reason, there will be 2 directions of field. So based on this, there is an interesting question. Huh? Why? Because at the point of intersection, there will be 2 fields. Two directions of E bar is not possible. So let me show you a question on this. There, this is a question. Let me do it on the next page. Read the question. He's saying there are 2 charges, Q1 and Q2. They occupy fixed position. This curve which is there is equipotential. He gave it, he said this is equipotential, doubt ही नहीं है. But this is crossing here. So we are actually contradicting our own point. We are saying it can't cross, but here I'm saying it is definitely crossing. And the potential iska voltage is 900 volts. The question is find the distance between the charges. Think how will we do this? It's a pretty good question. It's not tough. It is good one. Let's call it 38A. That whole curve is equipotential, not the whole thing. मतलब वो जो 8 shape है ना, that is equipotential. So my question is, this statement is true. They can't cross each other. This is also valid. How can both be possible? How can you make the statement 2 surfaces cannot cross each other? That is right. And you're saying they're crossing here. This is also right. फर्क नहीं पड़ेगा रतम 3D 2D कुछ difference नहीं है. No, they're crossing each other. Ammo. Diagram change मत करो. Let's get back to the statement. What is the problem? If the 2 points cross each other, problem क्या था?
Is there a null point?
I've got it. What is the problem here? If 2 points are crossing each other, there are 2 directions of field. Can you give me a vector which can have any direction? A 0 vector, right? तो एक ही possibility था. At this point of intersection, if the field is 0, you can have any direction of field, right? Are you getting it? So at the point of intersection, the field has to be 0. It's a null point. The point of intersection E has to be 0, since you can't have, direction is undefined. It cannot have two directions. Only a 0 vector can have any direction. That is a catch in the question. So be careful. Two surfaces cannot cross each other, but if they cross, that is a null point. 0 vector has undefined direction. That was a catch. Then question got over. Let this be R1. Let this be R2. Field is equal to KQ1 by R1 square is equal to KQ2 by R2 square. That is equation 1. Potential is scalar quantity KQ1 by R1 plus KQ2 by R2 is 900. Two equations, two unknowns. You'll get the answer from there. He's asking you R1 plus R2. Please check the steps. Yeah, you can calculate that, whatever is the number there, 9 centimeters. But are the steps clear, everyone? There, that is how you resolve that contradiction. You cannot cross, but you are crossing, means E should be 0. Good one. Clear. Any doubts on this? Labdi, clear, na? Got this? Hasni, clear? Amo, got this? Nishita? Arushi? Perfect. Next one. This is a HCV question.
So can you just show the previous slide for 2 minutes? Okay. Got it, sir.
Let's say we have 3 equipotential surfaces. This distance is 10 centimeter, or its potential 60 volt. This distance is 20 centimeter. This potential is 30. This distance is 60 centimeter. Potential is 10 volt. Find the magnitude and find the field in the region. These are equipotential surfaces. 3 concentric equipotential shells are given. Matlab in the region, na, 3 concentric shells are there. First of all, can you tell me the direction of field? It should be perpendicular to equipotential, na? Means it should be like this. Is it inside or outside? Is it this way or this way?
So field or the potential?
Field. Potential direction nahi hota hai.
Sorry. Field will be outward only.
Why? Reason kya hai?
Potential is
in the-
decreasing as you go outward.
In the direction of field, potential kya hoga? Decrease. So ये 60 था, ये 30 था, ये 20 था, 10 था. You're getting it? The potential is decreasing as you're going out. Think. I'll give you a minute on this. See, if you see, there's a relation here which is hidden. V into R is 60 into 0.1, which is 6. Can you see that? V into R is 6, V into R is 6, V into R is 6. No matter how much you multiply, the product is always coming 6, isn't it? So V is equal to 6 by R. Field is equal to minus dou V by dou R. That will be 6 by R square. That's your field in the region. In the previous question, Diana, it's every point on the curve surrounding the charges as shown in the figure. Net electrostatic potential created by charges is 900.
Like indirectly they've mentioned.
Indirectly क्या होता है? If I say this entire
Exactly.
shell is 900 volt, मतलब क्या होगा? Potentially same only, na? What? You want them to come and tell you, yeah, this is equipotential surfaces. Please welcome us. So that is the field. And what is the direction here? Direction will be radially outward. Because in the direction of the field, potential decreases. Clear? Easy? Got this? Haan, Trisha? Clear, na? Brinda, got this? Divyanshu, clear? Next one. This is D 10 centimeter, 0. This is 20 centimeter, 0. 30, 0 centimeter, 40, 0. This voltages are 10 volt, 20 volt, 30 volt, 40 volt. This angle is 30, 30, 30. So this is the green ones are the equipotential planes. Find field in the region. How we can you tell me the direction of the field again?
60 degrees downwards.
Downwards. So first of all, it should be perpendicular to the green lines, na? Which way, up or down?
Down.
Down, no? Dekho na, 40, 30, 20, 10, it is decreasing. Got it? I think by now you got the logic right, how to find directions. Magnitude kaisa karenge? See, we know the field is nothing but minus dou V by dou R. If you just want the magnitude, I can just take dV by dr. And since it is planes here, you can clearly see here, this is the perpendicular distance. Na? How much is that? This is 10 centimeter. This will be 10 sine 30. That is a perpendicular distance. So you can simply take the potential difference between two planes, 20 minus 10 by the perpendicular distance is 5 centimeter. So 10 by 5 centimeter is 10 power minus 2. That will be 200 volt per meter. That is the electric field. And what about the direction? Direction will be perpendicular to this. This is the Ivarka direction, making 60 degrees pointing downward. Clear? This is about relation between field and potential. So this is one part of it, and this is exactly same in gravitation. Usme to, did you observe one thing? I never wrote anything called charge anywhere. Dekha, till now all these questions we didn't field and potential. We never use the word charge. Only in the beginning definition there's a charge, but after that there is no charge anywhere. So exam they'll ask this only. Gravitation field is given, find the gravitational potential. Electric field is given, find the electric potential. The numbers will look exactly same. Clear? So this is one concept. The last concept we have in electrostatics is dipole. Meaning electrostatics is quite big. Uske baad Gauss law bhi hai, but we are doing electro, gravity, and then we're coming back to Gauss law. So again, I'm telling you, some of you have not mugged up all these formulas, because once you start gravitation, we have done actually most of the models. I will not be deriving those results again. I'll just write down the results, right? And we do different models on that. Problems so we will do, but results we need to mug up. We won't derive them again and again. For example, ये जो किया था ना last time, remember? अभी देखो, these kind of questions we will not do again. Why will we do this? This integration, this results, field, this, we will skip all these integrations. Sirf symbols change hoga, but you need to mug up the results. Next thing, dipole. You keep hearing this in chemistry. So what's a dipole? A dipole is nothing but a combination of two equal and opposite charges. It's a small concept. Dipole, right, is actually a mathematical concept than actually physics. So in dipole, there are certain set of formulas which you need to remember, right? If you know that dipole ka questions are quite easy, and exact same dipole ka questions, right, will come again in magnetism. The formulas look identical. There we'll call it magnetic dipole. So combination of two equal and opposite charges with distance between them. So for a dipole, if you have a minus q and plus q, the direction is taken like this. The direction is from negative to positive charge. If this is the distance d, p bar, that is a symbol for dipole moment, is charge into d bar. D bar is a vector from negative to positive charge. This is called a dipole. Where do you hear the dipole in chemistry? For example, if you have HCl molecule, if you see this is slightly positive, this is slightly negative. No? So actually it's a dipole like this. If you take a molecule like CCl4, it basically forms a tetrahedron. So this will be plus and minus of dipole, 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 and dipole. You're getting? So do you remember that is actually if you, how do you separate compounds? If you take methane CH4 and you react them with chlorine in a container, it forms different kind of molecules: CHCl2, CHCl3, CH4, Cl4, and everything. How do you separate them? If you have something like CH2, Cl2, it will have a dipole moment which is not cancelled out. So based on that, you can separate them. If you have these electrodes and everything. So you primarily use this in this, like chemistry. So basically, dipole is nothing but a combination of a negative and positive charge. So example, if I ask you like this, if you have 2q, if you have minus q, if you have minus q, they are on an equilateral triangle. How do you find the dipole moment of this? Remember, I told you dipole matlab it should be equal and opposite charges. How will we find dipole moment of this? Anyone? You can split this as plus q minus q, plus q minus q. So you can treat this as one dipole, you can treat this as one dipole. And dipole is a vector quantity, so 30 degrees and 30 degrees. You can write this as 2p cos 30 j cap, where p is equal to charge into side A. Got this? So if you have multiple dipoles, you can just treat them like vectors and get the resultant.
Sir, here we will take side means as distance between them or
Distance
side.
between them only, na? That is side only equilateral triangle ka.
Okay.
Right?
Yeah.
Suppose if you have minus q, minus q, minus q, and 3q. Square side A. What is the dipole moment of this square? What will be the dipole of this square?
Root 2 QD.
क्या करना था? This will be one dipole, which is q into A. This will be one dipole, which is q into A. This will be one dipole, which is q into root 2A, na? Isn't it? Q को 3 में split करते हैं ना? Plus q plus q plus q. This is one, and this is one. You'll get 3 pairs. Is that clear, everyone? The resultant कितना आएगा? So we have q root 2A, and these two will be q root 2A. So this will be 2 root 2 QA. Please check. So that entire square is like one big dipole, which is 2 root 2 QA along the diagonal. All clear with this? What will you for dipole for this guy then? Can I turn the page? A better question will be this. Let's say if I take a ring, right side is positive, left side is negative. इसका डाइपोल क्या होगा? What is dipole moment का formula? P is equal to Q into D power 1. What function is this? Linear function. If it's a linear function, who will come to help you?
Center of mass.
Center of mass. याद है? If the function is linear, how is center of mass का formula? Right? What is center of mass का formula? X center of mass will be nothing but sigma mi xi by sigma mi. What is dipole moment का formula? Dipole moment will be sigma qi ri. This is simply total mass ना, वो तो denominator constant है. Do they look same? Since dipole moment is a linear function, we can use center of mass concept. We can't do this for electric field. E is proportional to 1 by r square. V is proportional to 1 by r. We can't use center of mass here. That was the headache ना, इसलिए इतना integrate करना पड़ा. The dipole moment is a linear function. D power 1. So we can replace the charges at center of mass. Where is the center of mass of half ring, everyone?
2R about.
If you forget your center of mass values, you will get smashed. Be careful. So plus Q charge minus Q charge, ये center था. So this distance will be how much? कितना था center से distance? Anyone? Center of mass of half ring?
2R upon
2R by pi. 2R by pi. So dipole moment will be Q into 4R by pi I cap. Easy? Suppose if I take half disk, इसका क्या होगा? Disk. What is disk का center of mass?
3R by 8.
है 3R by 8 किसका होगा? Solid hemisphere is 3R by 8. Half disk is what? 4R by 4R by 3 pi.
Yes.
So dipole moment will be Q into 8R by 3 pi. I hope this is clear, everyone. Dipole का.
Sir, but if it is means function of x, then we have to integrate.
Integrate करना ही पड़ेगा. Then तो गया.
Okay.
You have to take small elements, then find the dipole moment for the small element, and then integrate. All clear with this?
Sir, taking element means same as the center of mass technique.
हाँ, concept तो वही हो गया ना.
Okay.
तो यहाँ पे element कैसा लेंगे पता है? यहाँ से we will take a small element है d theta d theta.
अच्छा, okay.
तो ये हो गया ना plus dq. ये हो गया minus dq. तो इसका एक dipole आएगा ना. उसका I cap J cap करके we'll integrate the elements.
Okay.
Now the results are more important. Right? Derivation is not important. Derivation is nothing but a big approximation. You are not interested. Electric field. You don't need to write this down. Potential due to dipole at far points. So these formulas are valid only for far away points. So actually dipole, right, is a mathematical concept which is useful for finding field and potential for large distances. So if this is the dipole from the center, if you're taking very far, actually dipole sort of bada draw kar liya maine. It should be small actually. This is R. Now the theta is measured from positive to negative angle. Theta is taken from plus Q towards minus Q. Remember that convention. So this head is plus Q, tail is minus Q. So this is a point P here. We have two things here. At this point, the field is given by 2kp cos theta by r cube. This is the radial component of field. Means it's the field away from the center. This is kp sine theta by r cube. How we got the derivation? We don't need it. This is tangential direction. So if you take the resultant of these two, E net magnitude, that will be kp by r cube, square them and add them. That will become 4 cos square theta plus sine square theta, which is 3 cos square theta plus 1. The potential at point P is given by kp cos theta by r square. This is the potential formula. This is the field formula. So the main condition here is this is valid only when r is much greater than d. D is the distance between the charges. Please put down this page. These are literally results. Questions will be direct questions based on this. And then I'll show you one or two advanced questions also. Then, like I said, it's a pretty small concept. Pull down, pull down. Copied everyone? Copied, no? So we have a dipole here. Wait, I forgot there's a cases actually. So case 1, if you take theta is equal to 0 degree, it is called axial line. That means if you have a dipole on this point here, there'll be only the radial field, which is 2 kp by r cube. There is no tangential component. Case 2, if you take theta is equal to 90 degrees, it's a perpendicular bisector. Means you're taking field on this line here. The field will be opposite to the field, opposite to the dipole kp by r cube. If you think about it logically, it makes sense actually. This is plus q, this is minus q. Plus q is pushing this way, minus q is attracting this way. Direction will be backward, na? The field is actually opposite to the dipole. Field won't be radial. Center se aisa nahi hoga. Be careful, huh? Most people goof up that. They think field will be like this. I think you can note down this part also. Axial and radial, this thing bisector. Pull down, pull it down. Clear? Let's see some questions. This is a basic question that Derrida's can bet something like this. So we have a dipole. On the axial line, there's a point A and there's a point B. This distance is R1. This distance is R2. Find R1 by R2 if EA is equal to EB. Simple question. If you know the formula, you'll get the answers. Get this, everyone. Direct result substitution. Clear? What is the answer? EA is equal to EB, right? So EA का formula is 2 kp by R1 cube. EB का formula is kp by R2 cube. So R1 by R2 will be 1 by 2 whole to the power of 1 by 3. Easy? कुछ नहीं था, substitution. Clear? Next one. So we have a dipole here on the origin, P bar. there is a point here A, which is 3 comma root 3. This is at the origin. Find the field at point A. Find E and V at point A. Let's get this. Everyone focus. Let's get this. Any answers? You have to be careful how you measure theta and all that stuff. What is theta here? See, I'll exaggerate the figure here. This is there, na? This is theta, na? Because theta is measured from plus q to minus q ka rotation. Got it? And what about this angle here? This is 3 comma root 3. Means the base is 3. This is root 3. So this angle is how much? 30 degrees, right? Tan theta, na, opposite by adjacent side, 1 by root 3. So this angle is 60 degrees. Sure, everyone? And what about r? R is equal to nothing but 3 square plus root 3 square. Distance directly, root 12. Or 2 root 3, that is the distance. So then you're done with the formula. What is the answer here? So this is the radial component. 2 kp cos theta by r cube. And remember, in the direction of theta, matlab, this is the tangential component. Kp sin theta by r cube. I hope everyone is getting how you're measuring this. People mess up the angles and the tangential component because you're rotating this way. So this should be the tangential component, right? You know everything here. You know k ka value, p ka value, theta ka value, r ka value. Please check. This thing, right? Most people get confused. They don't understand how to take theta, how to take the radial component. And radial will be theek hai. People don't get how to take tangential. They'll take this way by mistake. The tangential component is in the direction of theta ka rotation. Theta ka rotation goes from plus to minus q. So tangential direction is plus q to minus rotation.
So always it is plus q to minus q in this question.
Yeah, always. By convention, plus q to minus q. All got this? Question was easy, but it was just the convention that is more important than this. Clear? Any doubts on this? Anyone didn't get this? Please ask me how I got the angles, distance. Next one. We have a dipole here at the origin. Find the locus of the points where the field is in the y direction. Field can be in any direction, but there are some points where the field is in the y direction. Find the locus of the points where the field is along y-axis. Means there should be no horizontal component. I hope you know the meaning of locus. So if you take all those points and join them, what is that shape? Find the locus of all the points. Find the locus of the points where the field is along y-axis. Right, this is a good one. So somewhere here at angle theta. Two p cos theta by r cube. Kp sin theta by r cube. Now what do from here? Right, I'll give you a minute. See, when you say the field is in the vertical direction, this is theta, this is 90 minus theta. What does it mean? The horizontal components cancel out, right? If E bar is along y-axis, means horizontal component should cancel out. That means 2kp cos theta r cube ka cos theta kp sin theta by r cube ka cos 90 minus theta, that is that. So we end up with 2 cos square theta is equal to sin square theta. So we get tan theta is equal to plus or minus root 2. Isn't that the slope of a line? So that is nothing but y is equal to plus or minus root 2x now. Y is equal to mx. Is that clear, everyone? So this is the locus of the two lines. Basically, this line and this line where tan theta is root 2. On these two lines, the thing is 0. The field is the horizontal direction is 0. There's only vertical component. Easy? There's a catch in the question. Check. Clear? It's a good one. Brinda, clear? Devanshu, Hasni, clear? What happened, Hasni? Tired? Next thing. Dipole-dipole interaction. These are good questions also in theory also. You need to remember the results. They came in advanced ones. Advanced mein they asked you like dipole-dipole interactions is proportional to r power what?
Sir, this is in chemistry also, no?
But this is where we solve how to get them. Case 1. So listen carefully. Like this is it can be asked as a problem. You can also say this is a theory. So let's say this dipole is P1 and this dipole is P2. Both are placed in the same way. The distance between the dipoles is r. R is much larger than the distance, than the length of the dipoles. Basically, dipoles are very small. Now listen to the concept, okay? This is a good one. So this dipole P1 is there. P2, I can write this as minus Q and plus Q, and the distance is D. Agreed? Now remember, I don't know Q, I don't know D, but I know P2 is Q into D. So whenever you want to find force between two dipoles, what you do, you take the field of one guy on both the charges, isn't it? So from here to here, let the field be E. And let the field be E plus D. Agreed? Because the distance is different. Let the field due to P1 be E and E plus D. It changes slightly on the charges of Q2. Okay, so DE is a small change in field. So what will be the force on this? So the force will be Q into E plus DE, charge into field, minus Q into E, agreed? This is nothing but Q into DE. Is that making sense? So this is for a small distance dr. So this can be written as Q into dE by dr into dr. Agreed? But what is Q into dr? P2. And what is the field due to dipole? 2 kp by r cube. So what is dE by dr? 6 kp by r power 4. I just need to differentiate that. Substitute here. 6 kp1 by r power 4. This is the result. 6 kp1 p2 by r power 4. You need to mug up the result. It is 1 to the power of r power 4. Are you getting the idea what we're doing? So let the field be E on minus Q, let the field be E plus DE on plus Q. The force will be Q into D multiplied and divided by dr. So what do you got DE by dr? Rate of change of field. So just let me write the result on the next page. So if you have P1 and if you have P2, they both will repel each other. The force between them, actually in this case, they'll attract each other. Minus 6k P1 P2 by r power 4. Attraction, because the negative charge is closer to the positive charge. If they're like this, they repel each other. It is plus 6k P1 P2 by r power 4. Because the positive like charges are closer. Where r is the distance between the centers. Similarly, the potential energy, right? This potential energy will be 2 P1 P2 by r cube. This potential energy is plus 2k P1 P2 by r cube. How did you get that? F is minus du by dr, na? So we get du is equal to minus integral f dr. Integrate कर लेना f को, आंसर आ जाएगा भाई साहब. That is one way to do. These are the main results. I think I'll write down all the results here. If you take another case, if P1 is this way and P2 is this way, both are perpendicular. And r is the distance between them. This force will be 3k P1 P2 by r power 4. This will become 3. Potential energy will be 0. Right? देखो now. This is plus, minus, both are equidistant, na? Potential is 0. So there's no potential energy here. These are important results. Direct exam equations. These are matrix matching. They asked in advance. The force between dipoles is proportional to what? On the right hand side, the 1 by r, 1 by r square, 1 by r cube, 1 by r power 4. Left hand side, mein force between dipoles, potential energy between dipoles, electric field due to a dipole, potential due to a dipole. So they gave 4 on the left and 4 on the right, and they asked you to compare. This was a matrix matching in advance. 2000.
Sir, why it became 3 in when it is perpendicular?
अरे इक्वेटोरियल लाइन है ना, तो फील्ड का फॉर्मूला में ये 2 नहीं आएगा.
Okay.
This is an axial line ना, the axial line का field was 2 kp. यहाँ पे there will be perpendicular bisector है ना,
हाँ.
तो field will be kp by r cube ना.
Okay.
So when you differentiate this thing, ये 2 नहीं होगा यहाँ पे, so this will be just 3 here.
Okay.
Add this into the derivation. Results are more important everyone. Clear? Next thing. dipole in a uniform electric field. So if you have a dipole P bar, and let's say if you have a field E bar with an angle theta, so this is plus Q charge, this is minus Q charge. So you'll observe this will experience a force of QE, this will experience a force of QE backward, and this perpendicular distance, this is d by 2. So torque about the center will be Q into E. The perpendicular distance is d by 2 sine theta into 2 times, because there are two of them. This will be QD E into sine theta. Q into D is PE sine theta. This is the formula. So torque due to a dipole is given by P cross E. It's a cross product. Now you can do something here interestingly. If torque is equal to PE sine theta, I can write torque is equal to minus I alpha is equal to PE theta. And we can write alpha is equal to minus P into E by I into theta, SHM. So means if you put a dipole in equilibrium and disturb it, right, it will start oscillating. So the time period will be 2 pi root over moment of inertia by dipole moment into field. You can bring SHM here also. Means if you put a dipole like this and field like this, and if you disturb it, the dipole will oscillate like this.
Sir, I is
on a
not that
dipole.
point of intersection.
What? I about the central axis, no?
Okay.
I about the center of mass. Have a look at this, how it is.
So means
this
here,
is the what happened
here at that point from where it makes an angle theta.
Yeah.
Okay.
See, it will rotate about center of mass only. Na? Net force is 0. Center of mass will never move. So torque is 0, whereas the F net is also, torque is P cross E, F net is 0 because it's a couple. So in a uniform electric field, the net force is 0. All clear with this? Do have a look at this.
So, but net torque is not 0.
Net torque depends on the angle. Na? And we can write work done by external force is torque d theta, which is nothing but PE sine theta d theta. This will become minus PE cos theta. Limits theta 1 to theta 2. Work done by external force is nothing but change in potential energy. So U of theta 2 minus U of theta 1 will be minus PE cos theta 2 minus PE cos theta 1. So here what we do, we take theta 1 is equal to 90 degrees as a reference. Whenever you take potential energy, you always need a reference. Then the potential energy U of theta becomes minus PE cos theta. Like I said, derivation is not important, result is more important. Minus P bar dot E bar. So potential energy is given by minus P bar dot E bar. This is the second formula in this. That means if you take P bar this way and E bar this way, torque is 0 and the potential energy is minus PE. This is stable equilibrium. If you take E this way and if you take P this way, torque is maximum, potential is 0. There is no equilibrium meaning only. If P is this way, E is this way, because for equilibrium torque should be 0. U is plus PE. This is unstable equilibrium. There,
sir, in
in
SHM,
dipole.
in SHM, the part, like the point where the dipole will be aligned with the electric field, that will be the mean position.
That's a stable equilibrium. No? Remember, SHM always happens about stable equilibrium. You should come back now, right? Unstable, you won't come back.
And sir, the oscillation is like in the semicircle, na?
Huh?
Sir, can you draw and show how it is?
Draw kya hota hai? This is field. It is there. So this point is going like this, na?
Acha, okay.
Just like pendulum only. Kuch difference nahi.
Okay.
So example, how they'll ask you a question will be, this is E, this is P, this is 30 degrees. Find work done by external force if we rotate dipole 30 degrees anti-clockwise. Meaning finally it has become like this. So initial potential energy is minus PE cos 30. Final potential energy is minus PE cos 60. The work done by external force will be U final minus U initial. Clear? So you just take the change in potential and you'll get the answer. Any doubts on this? Please ask me. All got the steps? Dipanshu, getting this? Viksha? Geet, Labdi, clear so far?
Yeah.
Dipole is mostly how to by heart the formulas and stuff. Okay, it looks electrostatics and all like that, right? It is not that intuitive. So questions be aisa hi hoga. So just remember the formulas and finish off in HCV. It's not much. Last question for the day. Let's say we have a charge Q. So you took a dipole, is placed in the electric field of a point charge. So you took a point charge and you kept a dipole somewhere, anywhere you want. Now this is a non-uniform field. Huh? So this is non-uniform field. हमने जो भी derive किया था, it is for uniform field. So all those formulas, some of the statements won't be true. So the question is, which of the following statements are true? Which of the following are possible? Force 0, torque 0. Force 0, torque not 0. Force not 0, torque 0. Force is not 0, torque is 0. Means you can keep the dipole however you want. You can keep the dipole like this, kuch bhi karo. Keep it anywhere you want. Which of the following are possible? Can you have a situation where force is 0, torque is 0, force is 0, torque is not 0, and so on? Let's finish off last one for the day. With this, we are done with the chapter also. Now, HCV, you need to finish it off. Total, how many questions are there? 65, I guess. 70. Okay. How to do this? Any answers? Any guesses? Whenever they ask you something like this, right? Always think like this. Which kind of situation will give you this answer? When you think about that, you will be able to figure out. Can I get F0? Think about this thing. To make F0, क्या होना चाहिए? The force should be equal and opposite. right? Now, let me ask you another way. Let's go reverse, okay? Due to a dipole, is there any null point anywhere? Due to a dipole, is there a null point anywhere? No, right? There's not a single point with zero field. That means the point charge Q and the dipole will always have a force. By Newton's third law, if the force on Q is not zero, then the force due to Q on dipole won't be zero. Does that make sense? Are you getting the scenario there? That is one logic you can use actually. Or you can do something like this thing. I'll show you, see why you can't get a zero. Suppose if you put a dipole like this, see how will the force be? This force will be this way. This force will be this way. Both are equal in magnitude, but will they cancel out? So basically force can never be zero. Because if you try to make the directions opposite, magnitudes won't be equal. How to get torque zero? If you keep a dipole like this, देखो कैसा होगा force. So on this force will be forward, on this force will be backward, right? Torque is zero, no? But force is not zero. Are you getting? So what are the answers? Force can never be zero. Are you getting it? You cannot find a situation where force is zero. The best way to explain, right? You can actually use the alternative. That will be better. Since there is no null point for a dipole, force on charge Q due to dipole is never zero. By Newton's third law, force on dipole due to zero can never be zero. Does that make sense? This is more of a statement thing, but yeah, that's the reason. Please check. So these are the last two concepts left. If you see today, what we did, right, was more of a mathematical thing and results only. So dipole and the relation between field and potential. So you can finish off now all the 75 questions in it. We are done with the chapter. The next class on Friday will start off with gravitation. So make sure to go through all the results and come. Because first thing that I will do, I will just put down the results and we'll start doing questions directly in gravitation. Because gravitation mein kaisa hai na, there is no concept of induced charge. Means if you put a mass m, if you put another mass m, you won't get extra mass here. ऐसा कुछ concepts नहीं है. You don't have induced mass. You don't have repulsion. You're getting it? If you touch two masses, mass won't transfer from one point to another point. Conduction में होता था ना charge transfer. So all those cases will be gone. So like I said, electrostatics was a much superior chapter compared to gravitation in that sake. So what we will focus more is satellites in gravitation. That we didn't do. So make sure to go through all the formulas and come, right? Symbols only will change. So we will do that. So gravitation won't take much of our time. I think 2 to 3 classes maximum ho jayega gravitation. So that means you have to start solving parallelly with me gravitation also. That's what I'm telling you. By Friday, finish off your HCV electrostatics. Not much. Agar last time I gave it till 55, right? If you have done at least till 40, now it is 75, only 35 questions. It shouldn't be too much of a load. If you have not done anything, then it looks like too much of a load. And at least by Sunday, right? Sunday or Monday, try to finish off entire HCV, examples, objective 1, objective 2, and exercise of electrostatics. You need to do objective 1, objective 2, and examples also. Don't leave them. Quite important. Okay, this will wrap up for the day. So any doubts, anything, please stay back and ask. Chapter is done. We did almost 41 problems. So make sure to go through the notes first, finish off your HCV properly. If you're doing some other book, finish it off, whatever you're doing. ठीक. Then I'll see you guys on Friday as usual. So any doubts, anything, stay back or else you're free.